This is the workstation that we will be using for this exercise. The apparatus shown here is known as a force table. The markings on the force table allow us to precisely position forces using these pulleys at any place between 0 and 360 degrees. We will be using 3 of these pulleys to support pieces of string that hold the mass hooks. The opposite end of each string is attached to a keychain ring, which is kept in place with a pin. We can remove the pin to allow the ring to come to an equilibrium position. Be careful when removing the masses. If the pin is not in place or is removed when off balance, the masses may crash to the table. In the wooden box, you are provided with 50 gram and 100 gram masses. It is also very important to note that the hangers themselves have a mass of 50 grams. The lab procedure in your manual specifies the positions of the strings and the masses to be put on each hanger. During the experiment, you may also find that your ring is not perfectly centered while in equilibrium. This is because there are friction forces at play which we have ignored. You can move your ring to the center without disturbing the translational equilibrium. The purpose of Part 1 is to confirm equilibrium of the given setup and to state the conditions required for translational equilibrium. For Part 2 of the force table exercise, we need to make some adjustments to the apparatus. The first step is to install the plastic plate. Do this by removing the weight hooks and then replace the ring with the plate. Put the strings back in the pulleys and replace the weights to the same positions as the previous exercise. Next, 3 ball bearings are supplied to decrease the friction of the plate. Place these underneath the plate in positions resembling an equilateral triangle for best effect. Be careful with these ball bearings, they can get lost quite easily. Lastly, we need to adjust the third pulley so that the third string lines up with the line on the plastic plate. It will be in a different position than the first exercise. While adjusting, we also need to keep the other strings in line with the 0 and 90 degree mark. In order to do this, have one partner line up the 0 and 90 degree strings, while the other adjusts the pulley such that it lines up. It can be difficult to do this on your own. Once the apparatus is set up, release the pin and let the plastic plate come to rest. Then grab one of the pieces of graph paper provided and tape it to the plastic plate at the 90 degree corner drawn on the plate. You will then draw a line extending from each of the strings onto the graph paper. Be sure to write down the direction of the force and which mass is attached to which string on your piece of paper. It should look something like this. Use a pen instead of the chalk pictured here. This is just for demonstration purposes. The purpose of Part 2 is to calculate the torque about the center of the piece of paper. In order to do that, you must draw a perpendicular line from each of the lines drawn to the center as shown. After this exercise, you should be able to state the definition of rotational equilibrium and torque.